Hello higher chemistry students, and today's lesson continues with Unit 2 Nature's Chemistry, Section B, Alcohols. Again, a lot of this is revision. As you know from National 5, alcohol, in particular ethanol, can be made by fermentation. That's where we take a glucose source such as potatoes, grapes, apples, and we ferment it along with an enzyme present in yeast to produce alcohol. This alcohol is specifically for alcoholic drinks. For all other alcohols, we make them by a different method, which is catalytic hydration. Catalytic hydration involves taking an alkene, reacting it with water to produce the sister alcohol. So for instance, as the mechanism shows, if we take ethene, we add water by breaking the double bond to produce ethanol. If you want to make butanol, you take butene and hydrate it, and so on and so on. Alternatively, alcohols can also be reversed to go back to the sister alkene by dehydrating the alcohol. And as shown, this is the apparatus needed to do that. In order to do it, you would also need a catalyst, which has to be concentrated sulfuric acid. Please note that if you dehydrate larger alcohols, you can actually produce not just one, but several different isomers of the alkene. So for instance, by dehydrating butanol, we could produce but1-ene or but2-ene. So alcohols. All alcohols are another homologous series. They have the same general formula, CnH2n plus 1 OH, with the OH known as the hydroxyl group. Each member of the alcohol series starts with a prefix, meth, eth, prop, and so on, to indicate the number of carbon atoms within that particular alcohol. Alcohols can be straight chain or branch chain, and the position of the hydroxyl group can change. So there are steps to naming alcohols. New work. Now that we're in higher chemistry, alcohols can be of three different varieties: primary, secondary, or tertiary. Depending on the position of the hydroxyl group and how many other carbon atoms the carbon bonded to the hydroxyl group is attached to will determine its classification. Primary alcohols, the carbon attached to the hydroxyl group is bonded to one other carbon atom, as shown in this diagram of 2-methyl-butan-1-ol. Bearing in mind, all primary alcohols have one ol as their name ending. The hydroxyl group is always on an end carbon. Secondary alcohols, the carbon atom is attached to the hydroxyl group, is also attached to two other carbon atoms, as shown in this diagram of 3-methyl-pentan-2-ol. Please note, for a secondary alcohol, the hydroxyl group will never be on an end carbon. It will always be on the second, third, fourth, and so on and so on. Please also note that the branch cannot be on the same carbon as the hydroxyl group. That would then be known as a tertiary alcohol. Tertiary alcohols have a hydroxyl group. The carbon attached to the hydroxyl group is attached to three other carbon atoms, as shown in the diagram of 2-methyl-butan-2-ol. So we can see that the branch and the hydroxyl group are attached to the same carbon atom. Therefore, the name will indicate that the number of the branch is the same as the number of the hydroxyl group. Please note, alcohols do not necessarily contain just one hydroxyl group. Diols and triols also exist. Now over to you. Please try the exercises from Part B. Enjoy!